Hey guys, so here are the notes for the piecewise function introduction. Now, tomorrow you guys will be learning what piecewise functions are. Today, you're going to be seeing how can we graph linear equations with a domain restriction. Tomorrow, we're going to be doing a lot of graphing of linear equations with domain restrictions. Let's go ahead and look at example number 1. We have y equals negative 3x plus 4. Now remember, the general form of a linear equation is y equals mx plus b. Remember, m represents slope, while the b is the y-intercept. Okay? So usually when we do this, we just basically graph the y-intercept and then just use the slope to plot the other points. However, we can't do that on this problem. The reason being is we have a domain restriction. Remember, domain represents the x values or the horizontal axis. So we're going to have a restriction on what x values we can use. So notice it is saying that we have x is greater than or equal to 0. In order to graph this linear equation, we are going to use an xy table. When we're using an xy table, we are going to start at the restriction, meaning we are going to start at 0. Now, to figure out the rest of the x values, we need to follow this inequality. So since x is going to be greater than 0, that means we want numbers that are bigger than 0. That could be represented as 1, 2, 3, or you can use anything else that is bigger. Now what we're going to do is we're going to plug these 4 x values into our equation to get our y values. So you can use your calculator if you want to. So let's do plug 0 in. So negative 3 times 0 gives us 0, and then we're left with 4. If we plug 1 in for x, we get negative 3 plus 4, which just gives us 1. Now if I plug 2 in for x, I do negative 3 times 2 gives me negative 6, plus 4 gives me negative 2. And now I plug 3 into there, I have negative 9 plus 4, which gives me negative 5. Okay? So now we're going to go ahead and plot these points. Now this is going to go back to the ideas when we graphed on a number line the absolute value inequalities. Remember when we had an inequality and it had an equal bar? What that represented, meaning that our first point that we're going to plot is going to be closed. Anytime we have an equal bar, that means the point is going to be closed. I'm going to say a closed circle. Okay. Now, all the other points will have to be closed, no matter what. Okay. So let's go ahead. We're going to graph this. We're going to graph 0, 4 first. So I just go up 4, 1, 2, 3, 4, okay? And now I graph the other points. So I go over 1, 1, and then 1, 2, 3 over, and then negative 2, 5. Here we go. Or sorry, 2, or 3, negative 5. That's what it should be, 3, negative 5. Now, how do we determine where our line goes? Well, we are going to start from the very first point that we plotted, and then continue our line down. So I'm going to start from 0, 4, and then connect all the other points. And what we need is to have an arrow at the end. Now, can you guys recognize, going back to geometry, what this is? If you said it's a ray, you are correct. So now, instead of having one continuous line, we are now going to draw rays. So we're going to have a starting point, and then our line's going to go in any direction, and we're going to have an arrow. Okay, let's go ahead and let's look at example 2. I would like you guys to go ahead and pause the video to do example 2. Okay, let's see what you got here. So we have y equals 1/2 x minus 2 when x is less than or equal to negative 2. So here is our linear equation. Remember, we have y equals mx plus b. M is our slope, and B is that y-intercept, but we're really not going to use that to graph. We actually have to use a table. Here is our restriction. So when we are doing our XY table, we have to start at the restriction, whatever number that is. So I'm going to start at -2. Now notice which way this inequality sign is facing. We have x is less than -2, meaning I want numbers that are smaller. So hopefully you pick like numbers like -3, -4, -5. I'm going to go ahead and do even numbers because I do have a fraction I will have to deal with later on. Okay? So hopefully you picked the right way to go on that. Now we're going to plug our x values, okay? And then we're going to plug them into the x in our linear equation to get the y. So when I plug -2 into there, I should get -3. When I plug -4 in for x, I should get -4. When I plug -6 in for x, I get -5. And then when I plug -8, I get -6. Now, if you're like, well, how did you get those numbers? Just plug it into your calculator. Do 1/2 and then parentheses, -2, into parentheses, -2. Click enter, and then you get your answer, okay? Let's go ahead, we're gonna graph this. So I go over to the left 2, down 1, 2, 3. Now I'm at -4, and that's gonna be also at -4. And then I go to -6, -5, and then -8, -6. Now remember here, notice that I did a closed circle at -2, -3. The reason that I used a closed circle was because I have an equal bar on my inequality, okay? And then all the rest of the points are also going to be closed, no matter what. Okay, so don't forget, determine if the first point that your plot is going to be closed. Now to determine which way I'm going to graph, I'm going to go from the very first point I plotted, -2, -3, and then connect the rest of the points. And then I do an arrow. Don't forget, it's going to look like a ray. Okay, let's go ahead and do our next example, example 3. It's going to look very similar, but maybe a little bit different. So here's our equation, y equals 2x plus 1. When x is greater than 2. Oh, hopefully you guys have seen the difference here. If you look at example 3 compared to example 1 and 2, this one does not have an equal bar. That is going to affect one of our points when we graph it on the xy coordinate plane. But first, let's go ahead, let's plot our x, or let's go ahead, fill out the table, figure out our x values and the y. Okay, so don't forget, x is greater than 2 is our restriction. Now, even though it does not have an equal bar, we still have to place it in our table. That is going to be the first thing we place, okay? So no matter if the inequality has or has not an equal bar, that number needs to be the very first thing you put in your XY table. Now we follow what the inequality tells us. It's saying greater than 2. So I need numbers that are bigger. So that's going to be like 3, 4, 5, okay? Now I'm going to plug these numbers into my x. Once again, you can use your calculator. So I get 5, then 7, 9, and 11. Okay, now just like the last time, I'm going to have to decide how do I do my first point. Well, the last 2 times we had solid or closed circles because we had an equal bar. But we go back to our absolute value inequalities. Remember when we had to place those circles on our number line? If it didn't have an equal bar, what did we do? Well, remember, we said it would be an open circle, okay? So when we don't have an equal bar, your very first point you're going to plot is going to be open. But everything else still has to be closed because it will still be part of the domain. It's just whatever this point, 2, 5, will be open and won't really be part of the domain. Okay, let's go ahead and graph that. So I go over 2, up 1, 2, 3, 4, 5. I do an open circle. And now I just plot all the other points. Okay. Okay, just like we did before, when I connect the points, I start from the very first point I plotted, which is going to be 2, 5, the open circle, connect to the other points, and then I do the arrow. So it's still going to be array no matter what. Okay, let's go ahead and get to the next example. We have example 4. Okay, what I would like you to do is go ahead and pause the video and try this on your own. Okay, let's go ahead and do this one. So, here's our restriction. We have x is less than negative 4. Our equation is negative 2x minus 3. So when we do our xy table, remember, even though this does not have an equal bar, we have to start with the restriction, whatever number that is, on our xy table. That always has to be first, no matter what. Now we can follow what the inequality tells us. We want things less than negative 4. So that can be like negative 5, negative 6, negative 7. Make sure you went the right way there. Now we're going to go ahead and plug these x values into our linear equation where we see for x. So when I plug negative 4 in for x, I will get 5. When I plug negative 5 into there, I will get 7. When I plug negative 6, it's 9, and then I get 11. Okay? Now, let's think about that very first point we plot, negative 4, 5. Will that be open or closed? Hopefully you said open because we don't have an equal bar. But all the other points are going to be closed because they are included or part of the domain. Okay? So I go over 1, 2, 3, 4, up 1, 2, 3, 4, 5. That's going to be an open circle. Then I go negative 5, 7, negative 6, 9. And I don't really have room to graph the other point. That's okay. So now, do not forget, we are going to go from the very first point and connect to the other points. So go from the open circle and connect to the closed. There we go. And then don't forget your arrow because this is a ray. So it starts at what point, goes on forever in another direction. Okay, so that's how you graph linear equations when there is a domain restriction. Make sure to watch the next part of the videos. We're just going to go over how do you write linear equations. Okay? See you in the next video.